Stem and leaf plots. Stem and leaf plots are really useful when we have a lot of numerical data and we want to group it and see which parts of the data are more popular or more common. Is it more common that we'll find numbers in the 70s or the 60s? Do we have a whole bunch in the 50s and the 90s, but then nothing in the 70s and 80s, and so on? So I've got an example here that we'll work through. And the example is this. According to the CSIRO, changing rainfall provides evidence of climate change in Australia. Suppose that we count the number of rainy days each year for 9 years and find the following results: 67, 90, 54, and so on. Before analysing data, check that you understand what it means. These numbers here, what do they mean? So it's each year for 9 years. So this is the first year and the second year and the third year. And each of these is the number of rainy days. This year, there were 67 rainy days. This year, there were 90 rainy days, and so on. So before you start analysing the data, check that you understand what the numbers mean. Okay, now let's analyse it. We will create an unordered stem and leaf plot to show the distribution of rainy days. Distribution means which areas are more common than others. Okay, so stem and leaf plot. What we do is we write stem and leaf. We put a line down, and the stem, in this case, will be the tens column. We've got tens goes from 50s, 60s, all the way up to 90s. So I go 5, 6, 7, 8, 9. Notice that even if there were nothing in the 80s, like if there were no results in the 80s, you would still put an 8 there. You need to go up one by one, 5, 6, 7, 8, 9. You can't just skip one because there's no results there. Okay, so that's the stem. In this case, it's the tens. Now I have the leaf. Let's go through the results one at a time. 67 belongs in the 60s. So under 6, I'll put a 7. 90 belongs in the 90s. So under the 9, I'll put a 0. 54 belongs in the 50s. So I'll put a 4. 69, put a 9 here. 79. So do you notice that each result in the original data set matches one digit in the leaf section? To make this easier to read, we show the scale. This scale, I'll write 5 and then the line and then the 4 is 54. So that someone reading this can understand that this means 54. If your data was very small, let's say it was 1/10 the size and we had a decimal point on each of these, so our data is very small, then you might say 5, then the line 4 is 5.4. The distribution will look the same, but now it's clearer that this digit here represents 5.4. It's the same for if the data was very, very large. If all of these things were 10 times the size, 670, 900, 540, 690, and so on, then you might say that 5, line 4, is 540. And now this 5 here doesn't represent the 50s, it represents the 500s. It depends how big your data is. But for 2-digit data, 5, line 4 is 54. Okay, so now we can turn this unordered stem and leaf plot into an ordered stem and leaf plot. To do that, you can draw another one that has the leaf ordered. To be a bit more efficient with space, I'm going to show you that you just get the leaf section and put it in order. This one is already in order. 7-9 is in order. 9-0-3, we can shuffle that to be in order. 7-3, we can shuffle that to be in order. And that's already in order. Now this is an ordered stem and leaf plot. If you're doing this by hand, you would often have one unordered stem and leaf plot and then draw a second ordered stem and leaf plot. Looking at the stem and leaf plot, we can answer some questions. We can state the minimum and maximum values. The minimum value is the smallest one, which is this one right at the top. Not this one. This is a 0, but it represents 70. This digit here represents 54. So the minimum is 54, And the maximum is this one here, 90, 90. Do you notice that I've put units here to make it clear what this data means? Units aren't just maths teachers being fussy, but if I just put maximum equals 90, it's unclear what that means. Is this temperature, 90 degrees? Is this 90 years of rain? If I write 90 days, it's a little bit clearer that this means that the maximum measurement was 90 days of rain in the year. We can find the modal class. The modal class is the most common group. We've got the 50s, only one result, the 60s, two results, the 70s. So the modal class is 70 to 79 days. Even if this number here was an 8, you would still write 70 to 79 days because that's the group. How many years had less than 80 rainy days? Because we have all of the original data points in the original data, we can check this. This data point this year had 54 rainy days. This one was 67 rainy days. This one was 69 rainy days, 70, 73, 79. Oh, this one was too much. This was 83 rainy days. So we can highlight, I might even get out the highlighter, if I can find it. There we go, highlighter. Ooh. We can highlight all of the results that had less than 80 rainy days. And there are 1, 2, 3, 4, 5, 6 years, 6 results, where they had less than 80 rainy days. All right, make sure you get lots of practice. Check your answers as well to make sure that you're on the right track. And ask me for guidance when you need it. Bye, everyone.